Hello, my name is Patrick Peralta, and I'm a software engineer on the Oracle Coherence development group. Today I'm going to demonstrate the new configuration validation features in Oracle Coherence version 3.7. Coherence is configured using XML files. Prior to version 3.7, configuration was defined via XML DTD. When the configuration file is parsed by Coherence, validation is performed on the XML itself, for example, ensuring that each tag has a matching end tag. However, the XML elements themselves were not validated. Each component simply extracts the configuration that it is expecting, and in some cases an error is not thrown when an invalid element is present. Coherence configuration in version 3.7 is still based on XML. In this release, we have introduced XML schema to specify configuration options. We still ship DTD files, but we may no longer do so in future releases. In addition to validating XML structure, we now validate each XML element and attribute for valid content. There are numerous usability benefits to Coherence 3.7 configuration. At runtime, Coherence will fail fast when it encounters an invalid configuration file. This will prevent errors from occurring in a running cluster after it has been started. The use of the Coherence XML schema validation means that tags must be ordered correctly, so it is possible that existing configurations will need to be modified to work with XSD. XSD provides a richer validation framework for the content in XML elements and attributes. This means that at runtime and during development, each configuration option will be validated. For example, supplying alpha characters in a numeric field will yield an error. Now I will present two demonstrations of the Coherence 3.7 configuration validation feature. The first example demonstrates the feature during runtime, and the second demonstration will show validation during the development cycle. In this demonstration, we will start out with a typical cache configuration. Note that this XML file is using DTD. First, we'll start up a cache server using this cache configuration on the command line. Next, we'll start up a cache client pointing to the same cache configuration. Let's create a cache and put some data into it. Now we see an exception on the cache client. This exception indicates that there are no storage-enabled members in the cluster. This is unexpected because we previously started up a cache server. Now let's modify the cache configuration file to include the new XSD for cache configuration. Now let's switch back to the shell and restart the cache server. Notice that this time the cache server failed to start up. Let's scroll up and look at the error message. In this case, the problem was that the auto-start element was incorrectly specified. There should not be a dash between the words auto and start, a common mistake to make in a cache configuration. Let's correct the cache configuration and try again. Now this time the cache server starts up properly. So let's run the cache client again. and populate it with data. This time, everything works just as expected. As we can see, the strong XML validation can prevent runtime errors caused by invalid configuration. The next and last demonstration will show how the Coherence XML schema will help with configuration validation during development. I will give two quick demonstrations with popular Java IDEs, Eclipse and IntelliJ IDEA. Here I have a pre-existing cache configuration file, but the IDE doesn't have a way of validating the configuration. Let's add the XSD namespace information to the root element. Notice that this time I'm providing the namespace URL so that the configuration is fetched from the Oracle website. The website URL can be obtained from the Coherence 3.7 documentation, which is also on the Oracle website. After configuring the URL, we can now see that autocomplete works for the XML elements. In addition, we can see that the content of the file itself is validated. For example, I will configure expiry delay for this cache, which indicates how long items will remain in memory before they are evicted. I can indicate a setting measured in milliseconds, seconds, minutes, or hours. However, I must provide a valid setting in order for validation to pass. Note that if I put an invalid value in this field, the validation will fail. The benefit here is that we can see the failure before we ever attempt to start up a Coherence cluster member with this configuration. The same can also be done with IntelliJ IDEA. Simply indicate where the XSD is located and the IDE will pull it down and cache it. This concludes the Coherence 3.7 configuration validation feature presentation and demonstration. For more information on this and other Coherence topics, please visit the Coherence product page at oracle.com.